Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that a Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in the previous video, what did we talk about? If you remember, we started with the concept of open loop configuration. In this open loop configuration, I told you about three applications of Opamp. First one was differential amplifier. Okay. The second application was inverting amplifier, which was providing 180-degree phase shift between the output and the input. And third one was non-inverting amplifier. For inverting amplifier, what did we do? We connected the input at the negative terminal. For non-inverting amplifier, we connected at the positive terminal. Then I told you about the concept of feedback. And I told you why do we apply feedback. It is to stabilize gain. Okay. To increase bandwidth. Third one, to reduce distortion, to reduce environmental effects. Okay, that was the main purpose of using feedback. We saw that there are two types of feedback. One was negative feedback, other was positive. Negative feedback was when we were connecting feedback at the inverting terminal, and positive feedback when feedback is connected at non-inverting terminal. In negative feedback, the gain became A by 1 plus A beta. In positive feedback, it became A by 1 minus A beta. I told you this will be used in case of amplifiers, and this will be used in case of oscillators. And at last, we saw the most important concept, that was the concept of virtual ground. That I told can be applied when these two conditions are satisfied. The first one was open loop gain tends to infinity. Second one was negative feedback. And what we meant by virtual ground is the positive and negative terminal voltages will become equal, or you can say both the terminals are shorted. Okay. In that case, we can apply the concept of virtual ground. So in this video, we will be studying about some of the specification or characteristics of Opamp. We will not be talking about open loop or closed loop, but generally it is open loop only. So I will be talking about some of the terms that are related to Opamp, and I will be defining each and every term so that you can understand. The first term is called as the input offset voltage. Now see, what I told you about construction of Opamp, that there are 4 stages. The first stage, which is called as the input stage, what was that stage? The first stage was dual input, balanced output, differential amplifier. I also told you about its construction. In balanced output, how do we construct? This is the first input, this is the second input, and this is the output. Now in this case, generally what we say is V0 is proportional to the difference of the inputs. But that is not actually true. It will be true. It will be true if and only if both transistors are identical. But practically both transistor cannot be exactly alike. Both cannot be same. There will be certain difference in both the transistors. In that case, V0 is not equal to 0 when V1 is equal to V2. That is, even if you keep V1 equal to V2, V0 will be not non-zero. Similarly, V0 is 0 when V1 is not equal to V2. That means the characteristics that I was showing you passing through the origin was not practically true. Practically, how does the characteristic look like? It will look something like this. Okay, something like this. Now this is the difference voltage at which output is 0, and this is the output voltage when difference is 0. The y-axis intercept, what does it say? The output voltage when 0 difference is applied. And what does the x-axis intercept say? The input voltage required to make output 0. So in that way, what is the input offset voltage? It is the input difference voltage required to make output voltage 0. So this x-axis intercept is called as VIO, input offset voltage. Why input offset voltage is coming? It is coming because both transistors are not identical. Generally, this voltage lies between 15 microvolt to 6 millivolt. Okay, this voltage should be as small as possible because for ideal op-amp, the characteristics should pass through origin. So this difference should be as low as possible. Are you getting my point? If I ask you to define input offset voltage, what it is? It is the input voltage or input difference voltage required to make the output 0. So here also I have shown you VIO is V1 minus V2, where V1 is the voltage applied at non-inverting terminal, V2 is the voltage applied at inverting terminal. You keep changing this difference and try to observe using voltmeter that V0 must be 0. When this V0 is 0, then this difference V1 minus V2 is called as the input offset voltage. Is it fine? So that is the first definition that we need to know. The second one, output offset voltage. Just now what I have showed you is that the characteristics V0 versus VD, how they look like? They look something like this. This was the input offset voltage VIO, and this is called as the output offset voltage. So what is VOO? Is output offset voltage. What does it mean? It means output voltage when VD is 0 or V1 is equal to V2. When you apply the same voltage at both the terminals, then the output voltage is called as output offset voltage. Now, why output offset voltage is coming? Because V0 is not directly proportional to V1 minus V2. This direct proportionality can only hold if both transistors are identical. Which transistors? The transistors connected at the input stage of op-amp. If both are not identical, both voltages will have different value of gain, so output will not be proportional to their difference. What I mean to say is, if both voltage have different gain, then output will be V0 will be A1 V1 plus A2 V2. If A2 is equal to minus A1, for this to happen, both transistors should be identical. In that case only you can say V naught equal to A1 V1 minus V2. Otherwise, if gain of both amplifiers or both BJT is not same, then output voltage will be non-zero even if same input is applied at both the terminals. That is called as your output offset voltage. So if you remember it using the graph that I have showed you, it is very easy. Otherwise, directly memorizing the definition is difficult. The next definition is the input offset current. Now what is this input offset current? I told you the input stage is a dual input balanced output differential amplifier. So it is shown like this. In this one, we apply one input here, V in 1. We apply other input here, V in 2. Now the current here is called as base current of Q1 IB1, and the current in the second transistor is base current of Q2 IB2. One thing that I told you is no input current in Opamp. Why I told you that is because input current is the base current IB. If the input current is the base current and beta is high, then this IB is approximately 0. So remember how I am saying that there is no input current to Opamp, because the input current is nothing but base current of BJT, which will be 0 if your beta is very high. But practically, even if beta is high, input current is small but non-zero. Now since both BJTs are not identical practically, Q1 and Q2 are practically different. They cannot be exactly same. If they cannot be exactly same, then the input offset current is given as the difference of the two base currents. Okay, and we take the magnitude because we don't know which current is higher. So what does it indicate? It indicates mismatching of transistor. Because if transistors were exactly same, their difference would be 0. And here this current will lie between 6 nanoampere to 200 nanoampere. This current is very small, okay? But whenever you are solving numerical, you can assume that the input current to Opamp is 0, but practically the difference of the input currents is called as the input offset current. Next is your input bias current. Input bias current is simply the average of the two base currents. Their difference is called as the offset current and their average is called as the input bias current. Okay. So how you will define it? It is average of two base currents at the input stage of Opamp. Whatever the two base currents are there, their average is called as the input bias current. Okay, as simple as that. So 4 definitions I have told you. Input offset voltage. What is the input offset voltage? The differential voltage required to make output 0. Output offset voltage opposite. The output voltage when inputs are equal, and input offset voltage the difference in input when output is 0. Now input offset current, the difference in the base current. Input bias current, the average of the base current. Okay, moving on. Differential input resistance. It is basically input resistance at one input terminal with other input terminal grounded. Okay, that means you apply input at one terminal and ground the other terminal, and then the resistance that you observe is your differential input resistance. Is it fine? That is a simple definition, and it won't be used in gate electrical. This definition we use in gate ECE. There I told in BJT differential amplifier, this input differential resistance was 2 beta Re. There we derived this. Okay. The next and the most important term is the CMRR. Now this CMRR is called as, the full form is common mode rejection ratio. This is very important. Okay. Now what does this mean? It means the rejection of the common mode signal. Now what is this common mode signal? Those of you who have studied BJT differential amplifier might be knowing this. For those who haven't, let me define it for you. This common mode signal means the signal that is common to both the input terminals. Okay, that means the same signal is applied at both the input terminals, and that signal is called as the common mode signal. Now how does the same signal appear at both the inputs? Most of the times this common mode signal is nothing but the noise, because when noise is arriving in the system, then it won't check which input terminal you are talking about. It will always be common to both the input terminals. Okay, so that is why what we want, what is desirable is always that SNR should be high. What is this SNR? SNR is nothing but signal to noise ratio. We want at the output signal to noise ratio must be high. This signal is the output signal and this noise is the output noise. So we want that noise at input must be attenuated. Okay, the noise signal at the input must be attenuated so that the output noise reduces. So what does CMRR represent? It represents the ability of an amplifier to reject the common mode signal or to reject the noise. If an amplifier attenuates the noise, then it has a better CMRR. If it does not attenuate the noise, then it has bad CMRR. We want that only the input signal should pass to the output, but the noise must not pass, or the noise must be attenuated. Now we write V0 as superposition of two signals ADVD plus ACM VCM. This VD is called as differential input voltage. What is this differential input voltage? It is V1 minus V2. VCM is common mode input voltage, which is basically the average of the two inputs V1 plus V2 by 2. That is your common mode voltage. So AD is differential mode gain. Okay, and ACM is common mode gain. So we want that the common mode gain should be as low as possible and the differential gain should be as high as possible. So we define CMRR as AD by ACM. Now this ratio should be high, that is differential gain should be high and common mode gain should be low. This CMRR also can be represented in dB. It will then be 20 log mod of AD by ACM. Okay, this log is on the base of 10. So that is your CMRR in dB. So ideally ideally what we want is ACM must be infinite 0 or CMRR must be infinite. That is, the common mode gain should not be amplified, or the common mode signal should not pass to the output. Now we can also express V0 as A1 V1 plus A2 V2. Now I want to know about the common mode gain and the differential mode gain in terms of A1 and A2. Now how you can do that is, V differential is V1 minus V2. V common mode is V1 by 2 plus V2 by 2. So how we can find out the value of V1 and V2? See, simply VCM plus VD by 2. Because if you write VD by 2, it will be V1 by 2 minus V2 by 2. If you add both these, V2 by 2 will get cancelled, V1 will be VCM plus VD by 2. If you subtract both this, then it will become VCM minus VD by 2, that is V2. So V0 is A1 VCM plus VD by 2 plus A2 VCM minus VD by 2. That means if you collect the term containing VCM, it is A1 plus A2. Collect the term containing VD, A1 minus A2 by 2. Now we know V0 has one more form like this, ADVD plus ACM VCM. If you compare them, then this ACM is A1 plus A2 and this AD is A1 minus A2 by 2. Now this CMRR is simply AD by ACM, A1 minus A2 by 2 times A1 plus A2. Now you might be thinking that this CMRR will be less than 1 because in the numerator we have difference and in the denominator we have sum. But that is not true, because in Opamp or in any differential amplifier, if one gain is positive, the other gain is negative. If one input you are connecting at the inverting terminal, the other will be at the non-inverting terminal. So both gains are never positive. One gain is positive and the other gain is negative, due to which the difference of the gains will actually become addition and addition will become difference. So this CMRR is always greater than 1. So what you have to do when you want to find out CMRR? Find the gain due to V1 and find the gain due to V2. How? A1 is nothing but V0 by V1. From this equation I am writing V0 by V1 when V2 is 0. A2 is V0 by V2 when V1 is 0. So take one input at a time and find out the output voltage. You can find out A1 and A2. From there you can find out CMRR. Okay. Such kind of problem can also be asked in the GATE exam. The next term is called as SVRR. The full form of SVRR is supply voltage rejection ratio. I told you in Opamp there are two supply voltages. I am not talking about the two inputs, but the two supply voltage. The two supply voltages are shown here, plus V and minus V. So this supply voltage rejection ratio represents ability of Opamp to reject any changes in supply voltage. That means the performance of Opamp should not change even if we change the value of supply voltage. Now this supply voltage might be changed due to some surges, due to some fluctuation in the supply, but we want that Opamp should not be affected by change in supply voltage. So that is why this SVRR is written as dVIO by dV. That is change in input offset voltage divided by change in supply voltage. So that change ratio of the changes is called as your SVRR. Okay. The next term is your input resistance. So ideally we say that input current to the op-amp is 0. If input current to the op-amp is 0, the input resistance is Vin by In, that will tend to infinity. Or we can say, when we are drawing the model of the op-amp, we will show these terminals as open circuited. This voltage will be Vin. This is AV into Vin in series with R0. Okay. But practically this In is non-zero. It is the base current of transistor, so it is small. So this input resistance is simply Vin over In, which is high but finite. It will not be infinite. Okay. So this input resistance of op-amp is very high, but it is not infinite. Is it clear? Because this input current is always lying in the range of picoampere to milliampere. So this resistance would be very high, and that is the requirement of a voltage amplifier, that the input resistance must be high for a voltage amplifier. Next is your output resistance. Output resistance we show on the output side when we are showing a dependent source. Just now I showed you the network. The resistance in series with the dependent source is your R0. Ideally, this R0 is 0, because when we are talking about ideal voltage source, the resistance of the source is 0. So ideally R0 must be 0. But practically this resistance is non-zero. Practically it lies in the range of 100 ohm to 20 kilo ohm. Okay. So this resistance may be small, but it is non-zero. The next term is called as your output voltage swing. Output voltage swing is nothing but peak to peak undistorted output voltage. Okay. Now, as I have told you, in op-amp, when we draw the transfer characteristics, how are the transfer characteristics looking like? Initially it is linear, but when it reaches the supply voltage, it saturates. So if your output voltage lies between plus Vs and minus Vs, then it will lie in linear region. Otherwise it will be clipped. Let me take an example. If Vs is 10 volt and your output voltage is like this, suppose like this, up to 15 volt and minus 15, then we know it cannot exceed the supply voltage. Then what will happen? At 10 volt it will be clipped like this. That means the shape of the waveform will change due to clipping, and that is called as your distortion. So that means the maximum peak to peak voltage at the output is called as your output voltage swing. And how much can it be? It can be equal to 2 Vs. That is, it can swing from minus Vs to plus Vs. If it tries to go beyond that, in that case your output voltage will be clipped and the shape of the waveform will be distorted. The next is called as your bandwidth. So what is the bandwidth? Bandwidth I have defined multiple times. Bandwidth represents range of frequencies that can be amplified. Now in Opamp, what kind of coupling are we using? I have told you multiple times. Direct coupling. What is the advantage of direct coupling? That the signal passing is DC plus AC, which means Opamp can amplify. Opamp can amplify DC signal also. Remember, initially I was telling you, if we use capacitor between the two stages, then DC will not be able to pass. So whenever you are using coupling capacitor, you cannot amplify DC. If you want to amplify DC, you have to make use of direct coupling. If Opamp can amplify DC signal also, what should be the frequency response of Opamp? Those who have studied direct coupling might be knowing it already. How will the gain versus frequency look like? It will look something like this. Okay. This will be the 3 dB frequency FH. Okay. So this difference between the maximum gain is 3 dB. So this frequency response is starting from 0 frequency. That means this is the DC gain. The gain provided by Opamp to the DC signal. So FH is the 3 dB bandwidth of Opamp. But we know one concept in Opamp or any amplifier, that gain into bandwidth should remain constant. Okay. So if gain is A and bandwidth is FH, it should be constant. Now we define one more frequency which is called as unity gain frequency. This frequency is FT. This gain is 1. So frequency at which the gain is 1. Frequency at which gain is equal to 1 is unity gain bandwidth or unity gain frequency. So in that case, this A into FH will be equal to FT into 1, or you can say FT is A FH. So remember, what is speciality about Opamp? Opamp can amplify the DC as well as AC signal. So its frequency response will start from 0 frequency, and remember one concept always, that gain into bandwidth is always constant. The next one, open loop gain. We know open loop gain is nothing but gain of Opamp in absence of feedback connection. When we don't connect any feedback network, that is the open loop gain. This gain varies from 10 to the power 4 to 10 to the power 5. So this gain is very high. That is why to stabilize this gain, we were making use of your negative feedback. Also understand one thing. Just now I have told you gain into bandwidth is constant. If open loop gain is high, then this open loop bandwidth is low. So that is why we need to use feedback in order to increase the bandwidth of the Opamp. Initially in open loop configuration, the bandwidth is very low. The next term that we are defining is the slew rate. Slew rate represents maximum allowable rate of change of output voltage with time. Now why is this happening? See, when we are constructing Opamp using BJT, we know there will be certain capacitances involved. If there are capacitances involved, then they will take certain time to charge and discharge. If your output voltage is varying at a very fast rate, then capacitance might not be able to charge and discharge properly. So we have to fix a maximum rate at which the output voltage can change. Otherwise, capacitor will not be able to charge and discharge properly, and in that case output voltage will be distorted. Okay, if you want the capacitor to have sufficient time to charge and discharge, you have to maximize, or you have to put a maximum limit at the rate of change of the output voltage. So we say that dV0 by dt is called as the slew rate. It must always be less than slew rate of Opamp. This is the rated value that is given with Opamp. Your slew rate should always be less than the rating of the Opamp. What is the unit of this slew rate? It is volt per microsecond. Now suppose the input voltage or difference voltage is Vm sine 2 pi f t. That is a sinusoidal signal. Then V0 is AVD. So AVM sine 2 pi ft. Then we will find out the slew rate of the output voltage. So it will become AVM into 2 pi f sine 2 pi ft. This should be less than slew rate of Opamp. So from here we can have two limits, either on the maximum value or on the frequency. If you keep the frequency fixed, you can find out the maximum value of input voltage. If you keep the input voltage magnitude fixed, then you can find out the maximum value of frequency. So this slew rate will be written as A into 2 pi f into Vm. So we say the maximum value of dV0 by dt is the slew rate. That is why we are considering sine value as 1, because we want maximum rate of change. That maximum rate of change is called as your slew rate. So for maximum rate of change, the sine value is always 1. So let us summarize what we have covered in this video. I have told you about certain terms. First one was input offset voltage. That is the input differential voltage required to make output voltage 0. Output offset voltage, when input voltages are equal, the output voltage is the output offset voltage. Input offset current, that is the difference of the two currents. Input bias current, that is the average of the two currents. Okay. Then the next one was differential input resistance. Then input resistance, output resistance, CMRR. CMRR was 20 log AD over ACM. It also came out to be 20 log A1 minus A2 over 2 times A1 plus A2. Then SVRR, that is dVIO by dV. Then we talked about bandwidth. So here what we had to remember, gain into bandwidth is constant. Then we talked about slew rate, that is the maximum value of rate of change of output voltage with time. Now let us compare the values of ideal and practical Opamp for these parameters. Ideal Opamp and practical Opamp. So the first parameter is your input resistance. Ideally it must be infinite. Practically it lies in giga ohm range, because the current will be in nanoampere. Then output resistance. Ideally it must be 0. Practically it is less than 1 ohm. Very small resistance. open loop gain, ideally it is infinite, practically it is 10 to the power 4 to 10 to the power 5. Okay. Slew rate, ideally it must be infinite, because if capacitances are not present, the output can change at as much rate as possible, practically 100 volt per microsecond. CMRR, ideally it should be infinity because common mode gain should be 0, practically it is 80 dB. Okay. Then bandwidth in open loop, ideally it must be infinite, practically it is very small, 10 radian per second. That is your open loop bandwidth, which is very small. So this is the difference between the parameters that are observed for ideal op-amp and for a practical op-amp. In the next video, I will tell you about some problems based on these parameters. Thank you.
For 12 months, the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months, it will be 34650, and for 24 months, 39600. Believe me, my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here, it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for Iconic for 12 months, it is 5250. With code Ankit ESE, it becomes 45225, and 2-year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution, and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that, my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live, you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that, my friend, my personal Telegram channel also you can join, t.me/gateair1. Here you can get in touch with me, and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JE preparation can be done through these 2 channels, Unacademy SSC JE and GS Terminal. And you can refer the other channels to the other friends in respective branches, so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well, and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.